Here we come to DSE Physics 219 structure question 4. So here we have a conical pendulum which is set into a circular motion around a horizontal circle. So we have a bob tied to a string tied to a fixed point O. Part 1. You are asked about the bob's rotation rate. Basically, it's like the angular speed. Just the units we have to change into revolutions per second. We know that the omega, the angular speed of the conical pendulum, is 5 radian per second. So let's do the change in units. We know that's a complete circle. We have 2 pi radian. So if you go for 2 pi radian, you complete one circle. Now the angular speed is 5 radian. So how many complete circles are there? We can calculate by dividing it with 2 pi. So when we divide it by 2 pi, we got how many revolution per second. Okay, so 5 divided by 2 pi will get 0.7958 revolution per second. So this is the rotation rate. How many rotations each second? Part 2. Indicate on figure 4.1 the centripetal force required for the motion of the bob. So here you have to be clear about that. No matter how is the tension in the string, the bob is going along a horizontal circle. So this is the track of the bob. So in order to perform a circular motion, there must be a force pointing towards the center of the circle, and this would be the centripetal force on the pendulum bob. And secondly, we have to find the value for Fc by using Newton's law. F equals ma, and now the acceleration a is talking about the centripetal acceleration, so we can change the equation into this way. F equals mr omega square. Now note that this time we do not use F equals mv square over r because v is not given. So I'm not saying that this equation is wrong, but this equation does not help us to do the calculation because now the question gives us the omega. So we will just put in the numbers given in the equation. So we have the Fc equals m, mass of the bob. We have 30 grams. Of course, we need to change the units carefully. 30 grams divided by 1000 is 0.03. Radius of the circle. For radius of the circle, be careful. It is not 1 meter. This is not r. Why? Because 1 meter is talking about this length. However, when we talk about the radius, we are talking about the radius of the circular path. That is the length highlighted in green. However, it is good though because angle is given. This angle is 23.1. So we would very easily know that the radius would be equals to 1 meter times sine 23.1. Okay, so we can write down. I'm sorry, I mixed up. Let's go back. This angle is 23.1 degree. Alternate angles. So this length should be 1 times cosine 23.1, not sine, because this green line is touching the 23.1. So we will put cosine 23.1 for the radius. And for omega we just use it, so it is 5 radian per second squared. So here, what do we have is 0.690 Newton. Or more accurately, 0.6899 Newton. Now we will use more significant figure during our calculation, so that's if there is any calculation in the later part, it will be more accurate. But okay, it seems that there is no further calculation, so you can take 3 significant figure as the final answer. Now part 3, explain whether the magnitude of tension in string is greater than, equal, or smaller to the centripetal force found in 2. So we have to look at this. So we know that the centripetal force is actually originate from the tension that is present in the string. And if we try to resolve the tension into its vertical component, okay, we have T sine 23.1 degree, and also resolve it horizontally. The centripetal force is actually given by T cosine 23.1 degree. So, in other words, the centripetal force is provided by part of the tension. So which force is larger? Like, is it the tension is larger or centripetal force larger? Of course the tension is larger because Fc is just part of T, so T must be larger. So the centripetal force Fc is provided by the horizontal component of the tension. Mathematically, T sine theta or T sine 23.1 degree is equals to Fc. Therefore, the tension is larger